Think of the Earth for a second like a massive, incredibly complex computer system. Over the last couple of centuries, human progress has basically been running on some pretty outdated software, and frankly, the motherboard is overheating. Welcome to this explainer. Today, our mission is to figure out exactly how we can upgrade our planet's systems, from our factories to our farms to our exhaust pipes. We're going to look at how to mitigate climate change and keep our world running smoothly.
So, to really understand why this global upgrade is so absolutely crucial, we have to start with a pretty shocking number. Right now, a staggering 85% of the world's energy still comes from fossil fuels. Because of this massive reliance on them, the concentration of carbon dioxide in our atmosphere has pushed past 380 molecules per million, and it's just continuing to climb. And that right there is the heat-trapping gas actively warming our climate.
When you think of industrial emissions, you probably picture giant smokestacks, right? They really are the engine of human progress. But it brings us to the central question we really need to unpack today. How do we fix a warming planet without bringing all of this progress and the energy we literally rely on every single day to a complete halt? How do we keep the lights on without overheating the house?
Well, the answer lies in a concept called mitigation. Now, I know that sounds like heavy academic jargon, but it's really just a giant system upgrade for our civilization. It means taking direct action to slow down climate change by actively reducing the greenhouse gases we're pumping into the air. At the end of the day, it's all about efficiency. It's about doing more, or at least the same amount, with far, far less waste.
Okay, here is our roadmap for the explainer today. We're covering the global warming challenge, upgrading our industrial processes, farming for the future, catching carbon emissions, a look at some common climate misconceptions, and finally, a summary and next steps. Let's dive in.
Section 2. Upgrading our industrial processes. Basically fixing the factory. It's no secret that human activities, specifically rapid industrialization, have caused a massive, steep spike in carbon emissions over the last few decades. But here is the incredibly hopeful part of the story. We actually have the proven technology right now to reverse this trend. We don't have to sit around waiting for some science fiction invention. The tools are literally already in our hands.
Modern industries actually follow a specific step-by-step playbook to manage greenhouse gases. It's a hierarchy. Step 1. Avoid generating emissions entirely whenever possible, maybe through smarter building design. Step 2. Reduce the energy you do consume by making equipment super efficient. Step 3. Replace dirty fossil fuels with renewables, like solar or biomass. And then finally, Step 4. Offset whatever unavoidable emissions are left over by investing in things like forestation projects. Let's look at how this hierarchy plays out in the real world. Take cogeneration, for instance. There's sugar factories out there that capture the waste heat generated from making sugar, and they actually reuse it to power their own facilities. It's a pretty sweet deal for their energy bills and their emissions. Then we have zero-emission developments, which are entire building complexes designed from the ground up to run without fossil fuels. On a smaller, everyday scale, just swapping old incandescent bulbs for LEDs creates massive economy-wide efficiency. And out on our roads, hybrid vehicles use regenerative braking, literally capturing the energy that's usually lost when you hit the brakes to recharge their batteries. It's all about plugging the leaks in the system.
Section 3. Farming for the future. Optimizing the farm.
So, how do we feed a growing planet without just cutting down every remaining forest for farmland? Scientists rely on something called total factor productivity, or TFP. I know, more economics jargon, but it's actually a beautiful concept. It simply means working smarter, not harder. It's a pure productivity boost. TFP is about using technology to grow more apples, wheat, or corn on the exact same plot of land, but using less water and less fertilizer to do it.
We're basically looking at a fork in the road here. If we stick to business as usual, we're facing higher greenhouse gas emissions, severely degraded land, and ultimately much lower crop yields, which means people go hungry. But the towards sustainability scenario paints a vastly different picture. By making major investments in green tech and high-efficiency farming, we protect our natural resources while still producing plenty of food. It's a pretty clear choice, right? The harsh reality is that our arable land, the good land we can actually use for farming, is shrinking fast. We're losing it to urbanization, to soil degradation, and to climate change itself. To survive this, sustainable farming needs some incredibly smart linkages. We're talking about integrating crop and livestock systems together so the waste from one actually feeds the other. We're also talking about precision agriculture, where GPS-guided tractors deliver exactly the right amount of water, drop by drop, only to the plants that actually need it.
Section 4. Catching carbon emissions. Managing the exhaust.
Okay,
But what happens when, even with the absolute best factories and the smartest farms, we still produce carbon emissions we just can't avoid right now? What do we do with them? Well, we bury them. The formal scientific term is carbon sequestration. Think of it like a giant, incredibly secure underground vault for our atmospheric exhaust. It's the process of capturing the carbon dioxide produced by power plants and heavy industry and securely storing it deep underground or beneath the ocean floor so it never reaches the atmosphere to trap heat.
You might be wondering, how do we actually catch an invisible gas? Get this, you probably interact with this technology all the time. The exact same chemical systems currently used commercially to carbonate your favorite fizzy soda or to manufacture dry ice can actually be scaled up. Engineers are actively working on taking that same scientific process and placing it right inside factory smokestacks to grab the CO2 before it floats away. It's just a brilliant crossover between everyday consumer tech and global planetary rescue.
Section 5. Common Climate Misconceptions. Myths versus reality. Let's clear a few things up.
It's really easy to hope for a magic bullet. You might think, hey, let's just plant massive bioenergy forests everywhere. Trees are always great, right? Well, the reality is a lot more complex. The data shows that if we just plant massive monocultures, which is millions of the exact same type of tree for biofuel, and we use natural forests or local farmlands to do it, it can actually severely harm local biodiversity. It can even threaten the food security of local communities. Nature requires a delicate balance, not just a single blanket solution.
And that brings us to a really powerful finding from the source data. Boosting energy use efficiency and reducing greenhouse gas emissions must happen on an economy-wide basis. Basically, what this tells us is that just fixing the cars isn't going to be enough. Just fixing the farms isn't enough. We can't operate in silos. Upgrading the planet requires a totally interconnected, sweeping transformation across every single sector of our global economy. Section 6. Summary and Next Steps. Let's talk about your role in the upgrade.
Let's do a rapid recap of our planetary system upgrades so it really sticks with you. Pillar 1. Upgrading industry by plugging energy leaks and switching to super efficient tech like LEDs and hybrid engines. Pillar 2. Smarter agriculture by boosting total factor productivity, meaning we use green tech to grow a lot more food with less land and fewer resources. In Pillar 3, catching the exhaust by scaling up carbon sequestration to safely bury the stubborn emissions we can't completely eliminate just yet.
So, I'll leave you with this question. What small upgrade can you make to your own energy use today? Whether it's choosing to cycle instead of drive, making sure you turn off the lights, or checking where your products come from. Every single action is like a line of code in our new, upgraded planetary software. If humanity is the operating system for planet Earth, are you going to be a bug in the system, or are you going to be the patch? Stay curious, stay focused, and go upgrade your world.